In this video, we will be talking about how to find z-scores and how to work with z-scores using Microsoft Excel. Since Excel is free for our use and you can use it online or you can have that in your computer since it's free for all of us. Okay, understand is a z-score for each value of a data point is simply the distance from the mean. If this is the mean, then there's one value that you want to figure out how far this value is from the mean, then that distance is known as the z-score, right? So you can think in that way. All right, now let me demonstrate few things in Microsoft Excel. So here I have a data set, height, weight and gender, and I'll have this ready for you just below the video. Okay, and you can download this data file and then work on it. Okay, so for me, I just want to since this is a fairly large data file, I'll just want 100 people, 100 people and their weight in pounds. Okay, so let me just go for something just like, okay, all right, 301 people means basically I am weight of 300 people. Okay, since the first one is simply the header. Okay, so weight is in terms of pounds. Okay, now here I would first want to go for the z-score. So let me write down z-score for this one, and I will use the traditional formula for z-score. Okay, which is what? Which is z-score is simply z equals to x minus mu divided by the standard deviation. Okay, I'll be using that formula in there. Similarly, let me go for z-score. That would be z-score using Excel. Okay, z-score using Excel, and see how they match. And now I would go for z-scores probability, and then I will be going for probability by using the x values. Okay, the data points, simply the probability of x values. Okay, this one is simply the probability from x values. Okay, so these are the things that I'll be doing over here, so that's fine. Okay, now what you need to realize over here is you can clearly see that there are 300 data points. Okay, so you can go over there. 301 is the last row and the first row was the header, so that looks fine. And now here for z-score we need to figure out what is mean and median. Okay, so mean and standard deviation. So mean is, you can go for equals to average, and what is your data point? What are your data points? Data point is STDV, again the same thing, from B2 up to B301. Okay, so that's it. All right, so that looks good. So this is our mean and standard deviation. Okay, that looks fine. Now let us figure out the z-score by using the traditional formula, the formula that we know. Okay, so I would simply write down this to be equals to x, right? First start with this parenthesis, and what is x? X is the weight of each person. Okay, person who is in row number 2, this one, minus the standard deviation, sorry, minus the mean. Okay, divided by the standard deviation. Okay, so that's it. All right, so that's our z-score. So negative z-score means that this point is below the below or towards the left of the mean. Okay, and positive z-score means it's towards the right. Okay, so but whenever we go for this formula, then we need to make sure that this this mean and standard deviation doesn't change. Okay, so if you just drag it down, then it will change, mean and standard deviation will change, and the whole thing goes wrong. Okay, so to fix this mean value of mean and standard deviation, you just need to fix this by adding a dollar symbol. Okay, $I, $2, and here also $I, $3. Okay, this way it won't change the mean. Okay, so here also you can see that it's again the same thing. Okay, so now double click on all of these things, then you will be seeing that all the 300 data points will have their z-score. Okay, so it was fairly straightforward. We have the formula and we just input everything over there. Okay, so now let us so this is the way how we go by using the traditional formula. Now if you don't want to use the traditional formula, then we have a formula which is this one, equals to standardize. Okay, so standardize, standardize. So it's already populated over there, and once you start the parenthesis sign, then you can see the x value, which is this one. Okay, and the weight, and mean is this one, and standard deviation is this one. Fairly straightforward, right? So x value is this one, right? And what is the mean? Mean is this one, and standard deviation is again this one. Okay, so that's it, and it automatically calculates the z-score for you. And once again we all know that this I2 and I3 should not be changed whenever we are calculating these things for others. Okay, so that's why what we do is we again fix it. Okay, we fix this so that it won't change later on. Okay, once you do that, then you'll be getting the same thing. Okay, we are actually getting the same thing over here, right? Okay, yeah, so double click on the right bottom, and then you'll be seeing this thing. Okay, and you can see that they're actually the same thing, the z-score. Yeah, this is done manually, this is done using the standardized formula. Okay, so that's how you find out z-score for that. Okay, now z-score probability. So once we have standard normal distribution, so we definitely understand how it will go. Okay, let's suppose this is the normal distribution over here, and suppose your z value is over here. Then how do you find the area that is over here? Okay, let me just fill this up. Okay, what is this green area? If you want to find the probability underneath this z value, then how do you do that? Okay, and we already know that for this point, let's suppose z is z equals to 2.5, let's say, just for our consideration. Okay, so what is the probability for z is less than 2.5? Okay, and what is the probability that your z-score would be greater than 2.5, right? So this is actually 1 minus probability of z is less than 2.5. Okay, so since they are actually complement to each other, right? Since if you try to look onto this kind of situation over here, let's say, okay, so yeah, let me make sure that it doesn't flow away. Okay, so if you go for this, if you want to find the probability of this orange region, then this would be the probability. Okay, the green one, the green area, its probability is this one. Okay, so underneath the z-scores means what is the total probability that a point chosen is 2.5 distance apart or less than 2.5 distance apart from the mean. Okay, so that's the green colored portion. And what is the probability that a point we choose lies in the orange region, or it is far 2.5 distance far from the 2.5 standard deviation far from the mean is this one. Okay, so that's it, that's the orange one. Okay, so to go for that, we have a formula for that as well. So let us go for that, which is z-score probability. We have a formula that is equals to norm dot s. Okay, norm dot s dot dist means it assumes, okay, standard normal distribution. What is standard normal distribution? Standard normal distribution is such a distribution whose mean is 0 and standard deviation is 1. So that's the standard normal distribution. Again, it's 1. Okay, standard deviation is 1 and mean is 0. Okay, it assumes that. Now once you have z-score, then the z-score is always in the form of standard normal distribution. It always has 0 is the mean and 1 is the standard deviation. Okay, so let's go for that. Now these are the z-scores, right? So z-scores are over here in D, okay, in the column D, and cumulative means do you want to add up all the probabilities below that? Okay, do you want to add up all the probabilities below this z-score? Yes, we want. Okay, so let's go for true. Okay, sometimes by default it's true. For z-score probability by default it's true, but in some cases you may not want to do that. Okay, there are a few cases. Okay, so that's fine. Then you again go for the same kind of thing over here. Okay, so we found out all the probabilities below these z-scores. Okay, so what is the probability of x? Now let us use the normal formula, okay, the usual formula to figure out the probability distribution, probability of getting these values. Okay, so we are talking about these values, not the z-scores over here. Okay, so that would be simply equals to, just go for the norm.dist. Now since this formula is not assuming that the distribution is a standard normal distribution, okay, since we know that we are working with this distribution whose mean is this one and standard deviation this one, so that's not a, and this value does not refer to a standard normal distribution. Okay, whereas the z-score always gives us a standard normal distribution with mean 0 and standard deviation 1. So norm.dist is for any normal distribution. Okay, so x value is this one, comma, standard deviation is this one, sorry, mean is this one, and standard deviation is this one, and cumulative, yes, we want. Okay, so here also we need to go for the same thing. Alright, so that's it, and we need to realize that and you can see that the z-score probability for this one, for 152, x value 152 is same as the probability that that we got over here. Okay, and you can drag it all the way down, but before that just fix this thing. Okay, $I, $2, $I, $2, 3. Okay, all right. So then if you just double click on here, then you can, if you want to figure out something just like let's say what is your z-score? Okay, what is your z-score? Let's suppose my z-score is 2.76, and how do you like to figure that out? Then what is the probability underneath this z-score? Then you can clearly see that it would be 0.99. Okay, so this is all for this video. If you have any questions or concerns, please let me know. Thank you.